welcome to CEC lectures. Myself Dr. Preeti Chagwani from Department of Computer Science, Aribhat College, University of Delhi. So as you all are aware that presently we are going through our series of database management systems, and in our previous lectures we have completed the topic of normalization as well as data storage structures. We have also seen that how data is going to be stored inside the databases, in the forms of files, what kinds of files and so on and so forth. Now when we are talking about storing the data into some files, the ultimate idea is to retrieve the data as and when required. So we are storing the data because we need to retrieve the data. Now what is the way to retrieve the data? The way to retrieve the data is we will be kind of firing the queries and then we will be getting the data. But the important thing here is this access or this retrieval should be very efficient in terms of we can say time. Also the storage should be efficient in terms of the kind of memory requirements and so on and so forth. So here this is actually our today's topic, that whatever the data is being stored, how are we going to access that, how are we going to retrieve that data, and how fast we can retrieve the data, what are the techniques through which we can we will be able to retrieve the data, and that too in a speedy manner. And here comes our today's topic, which is about indexing and hashing. So in this lecture we will be going through the indexing techniques for database files. In order to understand why this indexing is required in case of databases, let us consider some queries, or let us consider examples of some queries. For example, the query is find all the instructors in a particular department, let us say physics department or computer science department. Or another, the query could be find the total number of credits earned by a student with a particular enrollment number or with a particular enrollment ID, let us say 22201 or something of that sort. So in both of these queries, you may notice that these queries reference only a small portion of the records which are stored in a file. So for example, we are talking about the instructors in all the departments. So they may be like 200 in count of hundreds, we can say, while we are talking about only for physics department. So maybe some tens or something. Apart from that, when we talk about total number of credits earned by the student with ID, with a particular ID, taking an example of 22201, we are talking about one particular student. And imagine in a university database how many students, data of how many students we have stored. So basically what is the fact which I am trying to establish here is we only need a fraction of kind of fraction or a small portion of the records in the file which these queries are referring to, or where our answer is actually located for the queries. Now this is going to be very inefficient if we are going to read every tuple in the whole relation. For example, in the instructor relation we have, let's say 900 tuples which are belonging to different departments, and we are looking for the physics department name, and we are checking each and every tuple. That's an inefficient idea. Another is, for example, if we looking for the ID 22201 and that too the number of credits earned by that particular student ID. So reading the entire student relation just to find that one particular tuple is also a very inefficient idea. So what should we do? So our system should be like that it is able to locate these required records directly. Now how it is possible? And in order to to allow this forms of access, we need some additional structures associated with the files, and these structures are none other than the index for the file. Now let us imagine an index for the file. For example, in order to retrieve a particular word from a book, let us take the example of a book. what are we going to do in this book with the help of the index? We are going to look for a particular word. So at the end of the books, if you have seen the index, that the your words which are kind of important words or keywords we can say are given in the sorted order, and the page numbers on which those words are being referred are actually given in the index. Similarly, we are going to associate a special kind of, we can say, structure with this with any database file, and that structure is known as the index. Or index for a file in a database system is going to work as similar as the index is working in for a particular or for any textbook. So the words in the index are in the sorted order, which is going to make the the process of finding the word easy which is required. Similarly, or moreover, we can say the index is much smaller than the book. That means it is further reducing the effort needed. So for example, looking for a particular word at the end of the textbook is actually kind of a very smaller effort as compared to looking for that particular word in the whole book because of the size. We can also compare the database system indexes having the same roles as of the book indexes in the book indices in the library. So for example, in order to retrieve a student record when a particular ID is given, the database system is going to look upon and look for an index to find on which particular disk block the corresponding record is residing. It is as as similar as we are looking for one particular word on which particular page it is residing, it is given in the index. Similarly, in the database index, one particular student record with an ID is given on which particular data block or is residing on which particular data block, that is going to be kind of stored there. So now if we are going to have the hold of the address or the number of that particular disk block, we can easily fetch the student record which is given inside that disk block. Now one question which comes up in the mind is, why don't we use sorting for this particular task? So for example, keeping a sorted list of a student ID is going to work here. That is something we can say we need to think upon. So I think it is not going to work here, or sorting keeping the data sorted here is not going to solve the purpose of the application, because keeping a sorted list of a student's ID would not work well on very large database where the number of students is is running in maybe 1000, because even if we talk about index, the index is going to be very big, but further keeping the index sorted is going to reduce the search time. So we are not maintaining the index in a naive way, we are maintaining the index also in a sorted way. So finding a student can still be kind of relatively easier rather than finding the student in a complete relation, even if the relation is sorted. And also more sophisticated indexing techniques we are going to use. So basically we will see that we are going to maintain an index. What what kind of information we are going to keep into the indexes, that we will see in a short while. But before going into that, let us consider what are the basic kinds of indexes. So basically there are two kinds of indices. One is the ordered index and another one is the hash index. So these are the two terms, basic kinds of indices. One is order indices and another one is hash indices. Now let us try to see the difference between these two, and let us try to kind of explore these. So ordered indices, as you can see on the screen, there are two types. Ordered indices, which is based on a sorted ordering of the values. So that means some sorted order of a particular field, we can say, on the basis of which we are going to make or we are going to create the index is stored. Another is the hash indices. So, hash indices is basically based on a uniform distribution of the values across a range of buckets. So, buckets, you understand, you take a bucket as, if you are not aware with the term hashing or hash functions, you can take bucket as a kind of a storage area, you can say. So, the bucket to which a value is assigned is determined by a function called a hash function. So, in ordered indices we have a sorted ordering of the values. In hash indices we do not have any sorted ordering of the values. Instead, we are going to have a uniform distribution of values across a particular range of buckets. Now, we have two types, as I have told you, that ordered indices and hash indices. Now, when are we going to use which particular technique? That means, what is the evaluation parameter for these particular techniques, when to use hash indices, when to use ordered indices. So, basically this choice of the technique depends on some factors on which these techniques must be evaluated. So, there are basically we can say 5 parameters for evaluation of these techniques. One is access type, another one is access time, third one is insertion time, fourth one is deletion time, and fifth one is space overhead. We will be taking them one by one. So, access type, when we talk about the type of access which the index is going to support efficiently. If your index is going to support efficiently a sequential access, or if your index is going to support efficiently a random access. So, this type of access we are talking about. So, which type of access is being supported efficiently is one way of the evaluation of the techniques of your hash indices or ordered indices. Apart from this, in the access type we can also include finding the records with a specified attribute value and finding the records whose attributes value fall in a specified range. So, we will be looking into the access types, that which access type is being suitable for which particular technique. Apart from that, the second and very important parameter is access time. So, access time, as the name indicates, is very simple. Basically, time to find a particular data item or set of items using a technique in consideration. So, for example, if we are using the hash technique or if we are using the ordered technique, which one is taking how much time. Apart from that, we also have insertion time. Insertion time is the time it takes to insert a new data item, and also it is not just the value that includes the time it takes to find the record. It is also going to take the time to update the index structure. So, basically we have within the insertion time we have two things. One is the time it takes to find the correct location where to insert the new data item, and it is not about only the insertion of that particular data item. Your index structure is also to be updated accordingly. So, that updation is also going to take some time. So, the location or the finding of location where to insert the new item, insertion of that particular item includes the time which is being taken to update the index structure accordingly. The fourth parameter is the deletion time. Deletion time, now let us say we are deleting a particular item. So, we need to find that particular item, we need to locate that particular item within the index and also within the database. After deletion, the index structure is to be updated accordingly. So, based on the similar lines of the insertion time, your deletion time is actually we can say a sum of two values, which is the time it takes to find the item to be deleted as well as the time it takes to update the index structure also. Next, after the so we have seen access time, insertion time, deletion time, and we have also seen access type. The last parameter is about the space overhead. Space overhead as mean, so for example, I have told you that index is something which is an additional data structure or which is an additional structure associated with your a database file on the similar lines as your index is associated with a particular book. So, index at the end of the book is definitely taking some space. Similarly, index for a database is going to take some space. Now, we need to see, what are we, that particular space is also a overhead, which is the additional space occupied by the index structure itself. Now, how much overhead we are willing to take? So, when we are talking about the overhead which we are willing to take or which we are willing to kind of compromise, so that depends on the performance. So, provided that the amount of additional space is moderate, it is usually worthwhile to sacrifice the space to achieve a improved performance. What does it mean? So, basically maintaining an index is going to take some space. Is it actually, the question is it actually worthwhile to give that much space or to sacrifice that much space? Yes, it is worthwhile only if you have kind of some performance improvement, and yes, your index structures are there to have or to provide the performance improvement to the database, especially in terms of access, deletion, access basically we can say. So, yes, maintaining the index is actually we can say is worth. Now, is it something that we need to have one index for one particular file? So, we will be saying that no, we can have more than one index for a file. So, for example, we are having a student we are having an instructor table or an instructor relation. So, one index can be according to the we can say the subject or the faculty of the instructor. Another is to another index for that particular file only can be according to the employee ID or something of that sort. So, in this way we can have more than one indexes for one particular file. Or another example can be to search for a book. We can that's a very common example you have seen in the library, that we can search a book for by the subject, by the title, or maybe by the author name. So, that means here we can have three particular indexes for a book database. One is for the title, one is by the title, another one is by the subject, and the third one could be by the author. So, here I have given the examples of three, but there can be many others, but yes, we also need to see the space overhead as we have seen. Now, an attribute or a set of attributes which is used to look up the records in a file is known as the search key. So, there can be many search keys, and according to those search keys we can have many indexes for one particular file. Then we have seen there are two types of indices. One is an ordered indices and another one is hash indices. So, after exploring the basics of indices, that what are indices, how these are maintained, and what are the qualities or what are the parameters one index should kind of maintain in order to have an smart evaluation or in order to have an efficient we can say performance, we are going to cover the ordered indices and hash indices. So, let us begin with our first type, which is ordered indices. So, ordered indices, as you can see on the screen, we have given one particular relation which is of instructor, which is of the instructor, and that instructor is having the fields which are given in the relation are the faculty ID, then the name of the faculty, then the subject of the faculty, and then the salary. Now, for this particular file, if we are going to maintain an ordered indices, the ordered indices could be of this particular type, which is given on the screen, and this particular index is given with the, or is created with the help of ID. As you can see that along with the that particular file, we have placed one special structure, or one structure which is placed on the left hand side in the figure, if you can see. So, we have all the IDs 10101, then 12121, then 15151, and so on and so forth. And this structure which is placed on the left hand side is nothing but a index. So, for example, if we want to kind of access a particular item or access a particular instructor row, which is, let us say one which is having the employee ID number 76543, we can directly go to 76543 and follow the link which is directly taking us to the we can say to the record. Now, what is happening here is, here all the index fields is given in the sorted order. So, it is not necessary that in the sorted order it is also given in the actual field. So, for example, let us say I am talking about the faculty, or the we can say the subject. So, here we have subjects as computer science, finance, music, physics, history, physics, then computer science, and these are not arranged in a particular sorted order. But when we are going to make the index, that index is going to be arranged in a particular sorted order. So, it is going to be very easy to follow that particular index, and we will be jumping directly to the required record if we are following the search criteria for your we can say subjects. Now, in order to understand it very clearly, let us kind of we can say formally begin with ordered indices. So, ordered indices basically says that we are going to make index structures, maybe multiple as in more than one for a particular file, and each index structure is associated with a particular search key. And in order to, why are we going to do this? So, I am just going to reiterate it here. To gain the fast random access to records in a file, we are going to use this index structure, and we can have multiple index structure for a particular file, and the records in the index file may themselves be stored in some sorted order, just as books in the library are stored according to some particular attribute, maybe according to their accession number we can say, or some libraries give it according to the different subjects, and then so on and so forth. So, if a file containing the records is sequentially ordered, we a clustering, we form a clustering index here. A clustering index is an index whose search key is also defined by the sequential order of the file. So, clustering index are also called primary index, and the example which we have just seen of this particular index which is given on the screen is actually a clustering index, in which the index key of the index structure is actually the primary key, and the key which I am talking about here is nothing but your ID. So, the search key of the index is the faculty ID. Similarly, the primary key of this particular relation is also that very field, which is nothing but the employee ID, and the structure, index structure is also based on the employee ID. So, here we can say that yes, this is the clustering index we can say, in which the primary key of the relation is actually the kind of search key of the index. Now, these clustering indices are also called primary indices. Many a times it happens that search key of the clustering index is the primary key, as we have seen in the example, but this is not a mandatory condition. It is not necessarily for all the example. So, indices whose search key specifies an order different from the sequential order of the file are called, secondary indices, or we can say non clustering indices. So, assume that we are having some files which are ordered sequentially on some search key. So, such files that have the clustering index on the search key are known as index sequential files, and they represent, this is actually one of the oldest scheme of maintaining indices used in the database systems, and basically they are required for the application which deals in both sequential processing as well as the random access. And this is why this is what when I was talking about the access type. So, here this clustering indices are something, or clustering indices fall inside the ordered indices. So, ordered indices are something which are designed for the applications that require both sequential processing of the entire file and also the random access to the individual records. And here we have also seen the example of that particular thing. So, an index entry or an index record contains a search value and the pointers to one or more records with that particular value, and the pointer to a record consists of the identifier of the disk block, so that your head directly read write head directly can jump to that particular disk block, and then offset within the disk block is also there to identify the record within a particular block, within a particular disk block when we talk about. So, here in this lecture we have seen the concept of indices, and we have also gone through one particular indices, which is about the ordered indices, and we will be covering the next one, which is the hash indices, in our upcoming lectures. Hope you have enjoyed this lecture. Here is a list of references which is being used for the preparation of the lecture. Thank you for a patient hearing. I will see you in the next one. Till then, take care. Goodbye.